In the last lesson, we learned about file handling, reading from and writing to files. In this lesson, we are going to learn about exception handling. You have already seen errors many times in this course. In the beginning of the course, we saw the syntax error. Also, we saw a value error when the user typed a word instead of number. In the last lesson, we briefly used try and except in our note-taker program. Here, we are going to understand all that fully. So, what is an exception? An exception is an error that happens while your program is running. It is different from a syntax error, which is a mistake you made in the code itself that Python catches before running. An exception happens during execution. When the program is already running and something unexpected occurs. For example, the user types a word when your program expects a number, or your program tries to open a file that does not exist, or your program tries to divide a number by 0. When an exception happens and you have not handled it, your program crashes and stops immediately. This is a bad experience for anyone using your program. Exception handling is the technique of catching those errors before they crash the program and responding to them gracefully, showing a friendly message instead of letting the program fall apart. Think about it like this. Imagine you are driving and a pothole suddenly appears on the road. A car without good suspension will jolt violently and possibly break down. But a car with good suspension absorbs the shock smoothly and keeps moving. Exception handling is like the suspension system of the program. It absorbs the shock of unexpected errors and keeps the program running smoothly. Let's open the terminal and go into our working directory. Let's create a new file for this lesson. Let's name it exceptions.py. Press I to switch to the insert mode. Then let's first see what an unhandled exception looks like. Let's start before input. Save it. Then let's run it. Let me enter a valid number first. Let me type 2. You can see that it worked. The result is 5.0. Now let me run it again, and this time enter 0. You can see that the program crashed with the zero division error. It says division by 0. Now let me run it one more time and type a word instead of a number. Let me type hello. Press enter. You can see that the program crashed with the value error. It says it cannot convert string to integer. Both of these are exceptions. Both of them crash the program completely. That is what happens when you do not handle exceptions. Now, let's fix using exception handling. The structure of exception handling in Python uses two keywords. The first one is try and the second one is except. The try block contains the code that might cause an error, and the except block contains the code that runs if an error occurs. Let me show you. Let's update the file. Press escape and save. Let's run the file. Let me enter a valid number 2. You can see that it worked fine. Result 5.0. Let me run it and type 0. You can see that instead of crashing, it printed something went wrong. Please try again. Now let me run it again and type hello. You can see the same friendly message instead of crashing. The program no longer crashes. The try block attempted the code. An error occurred and the except block caught it and responded gracefully. Now, the approach we just used catches every possible error with one general except. But Python allows us to be more specific to catch different types of errors and handle each one differently. This is better practice because it allows you to give the user a more helpful and accurate message. Let's update the file. Press escape, then save. Let's run the file. Let me type hello. You can see that it printed invalid input. Please enter a number, not a word. That is the value error message. Now let me run again and let me type 0. You can see it printed you cannot divide by 0. Please enter a different number, which is the zero divide error message. Now let me run again with a valid number. Let me type 5. You can see it worked perfectly. Result 2.0. So by naming specific exception types after the word except, Python only catches that particular type of error. If a different type of error occurs, it will still crash. It forces you to think carefully about what can go wrong and handle each case properly. But if you want a general except that will catch all the errors, the one you predict or the one you don't predict, you can use the one we used before, which is simply except without any specification of the type of error. Now, moving forward, Python's exception handling has two more optional keywords. apart from try and except. The two more optional keywords are else and finally. The else block runs only if the try block succeeded, meaning no error occurred. The finally block runs no matter what, whether the try block succeeded or failed, it will always run. Let me show you both. Press escape, then save. Let's run it. Let me enter a valid number 2. You can see the else block ran. Success. The result is 5.0 because no error occurred. And also the finally block ran. Program finished. Now let me run it again and type hello. You can see the except value error block ran. Invalid input. Please enter a number. Then the finally block still ran. Program finished. The finally block always runs. This makes it useful for things that must always happen, like closing a file or displaying a closing message regardless of whether an error occurs or not. Now let's look at some common exception types you will encounter in Python. Let's create a new file named specific exceptions.py. Switch to insert mode, then let's write the following codes there. Before we continue, notice the lines that start with the hash symbol. These are called comments. A comment is a note that you write inside your code to explain what the code does. Comments are meant for humans to read the code, not for Python itself. When Python runs your program, it completely ignores comments. To create a comment in Python, start the line with the hash symbol, just as I did in the first line and some other lines too in the code. Now, let's press escape and save. Let's run the file. You can see all 3 error messages, each one caught and handled gracefully. Let me explain each exception. The first one is FileNotFoundError. This happens when you try to open a file that does not exist. You already saw this in the note taker program from the last lesson. The second is index error. This happens when you try to access an index that is beyond the range of the list. Our fruits list has only 3 items at indexes 0, 1, and 2. Trying to access index 10 does not exist, so Python raises an index error. Then the third one is key error. This happens when you try to access a key that does not exist in a dictionary. The student dictionary has only name and age. Trying to access score raises a key error. These are some of the most common exceptions you will encounter as you write Python programs. Now, let's learn about raising your own exception. In Python, you can also raise an exception deliberately using the raise keyword. This is useful when you want to enforce rules in your program. For example, if you write a function that only accepts positive numbers, you can raise an exception if anyone passes a negative number. Let's create a new file named raiseExceptions.py. Switch to insert mode, then let's write the following codes there. You can see set age open bracket 26 close bracket worked fine. Age set to 26. But set age open bracket -5 close bracket raised a value error with the message age cannot be negative, and our except block caught it and printed error age cannot be negative. Notice the as e in the except line. Except value error as e. This stores the error message in the variable e, so we can print it. This gives us access to the exact message we wrote inside raise. Raising your own exceptions is how you enforce rules and protect your functions from being used incorrectly. Now, let's build a final practice program that brings everything together. Let's create a new file. Let's name it savecalculator.py. Switch to insert mode. Let's write the following codes. Save the file. Let's run. Let me enter two valid numbers and an operation. You can see that it calculated the result correctly. Now let me run again and try to divide by 0. You can see that it caught the zero division error and showed a friendly message. Now let me run again and enter a word instead of a number. You can see that it caught the value error and asked me to enter a valid number again, and kept asking until I entered something correct. This is because the function getNumber has a while true loop that only breaks when the input is valid. And notice that the finally block always runs at the end, whether there was an error or not, printing the thank you message. This is a fully protected calculator. It handles every type of bad input gracefully without crashing once. Now, let's push everything to GitHub. Let's go and check GitHub. You can see that our new files have appeared in the repository.